Alright, let's look at the homework 7.5, 7.6, problem number 2. Alright, so we have this function f of x comma y is equal to square root of x squared plus y squared. So we want to find critical points, and we have to determine if they give us a relative max, or relative min, or a saddle point. Alright, so let's do that. Alright, so we have to take the partial derivative with respect to x. So partial of f with respect to x is going to be, alright, so this is, I'm going to rewrite it as x squared plus y squared raised to the 1/2 power. Right, so derivative, so put 1/2 in front, keep the same inside function, subtract 1 from the power, so it's a negative 1/2, multiply by derivative of inside with partial of inside with respect to x, so that would be 2x. Alright, so if you clean that up, you see that, let's see, 2 on the bottom and 2 on top cancel out. So you're going to get, let's see, x on top. Alright, then you have a square root on the bottom. Then you have x squared plus y squared. Alright, set that equal to 0. Alright, then only way we can make that equal to 0 would be the numerator equal to 0. Alright, and we take the partial with respect to y. Alright, so put 1/2 in front, and then you have x squared plus y squared, and the negative 1/2 power, same as before, but the partial of inside with respect to y would be 2y. Right, so we can cancel those guys, and we get y over square root of x squared plus y squared, right, is equal to 0. Right, so this is going to be y equals 0. Alright, then we're going to take the, it looks like critical point is going to be 0, 0. Right, then let's do the second partial test. So f partial with respect to, second partial with respect to x would be, alright, so we have to use the quotient rule here. Square the bottom, so you have x squared plus y squared, square root is gone. Partial of x would be 1 times the bottom, so it's a square root of x squared plus y squared minus x times partial of the denominator is actually, we've done this before, you're going to get x over, so which is this, right? Because we take the partial of this guy, so it's a square root of x squared plus y squared. So I'm just using this guy because partial of this guy, or this guy, oops, partial of this guy is equal to that, so which is that. Alright, so then we just need to simplify, and I don't like having a fraction inside a fraction. I'm going to multiply top and bottom by square root of x squared plus y squared. Alright, then you end up getting, let's see, so we have x squared plus y squared. Distribute that, minus x squared over, let's see, so multiply together, so you have a quantity x squared plus y squared raised to the 3/2 power. Alright, so you can cancel x squared here and x squared there. You will get y squared over x squared plus y squared to the 3/2 power. Alright, so we have that. Then you have partial with respect to y. Right, and we're saying same deal, so we take the partial with respect to y, you're going to get the square the bottom. Right, then you have, let's see, so partial of y would be 1, times the bottom, which is square root of x squared plus y squared. Very similar to before, so it's a y, times partial of this guy with respect to y would be y over square root of x squared plus y squared. Alright, so you would get, let's see, before that, we're going to multiply top and bottom by square root of x squared plus y squared and square root of x squared plus y squared. Right? So this is going to be maybe I'm going to go back to blue. Alright, so we have x squared plus y squared, so multiply these out, and a minus, cancel those out, y squared. And the bottom is the same as before, and 3/3 power. Alright, so we can cancel y squared and y squared, and we get this guy, x squared over x squared plus y squared, and 3/2. Alright, and I'm going to go ahead and find the partial with mixed partial, so partial with respect to x, then partial with respect to y. Alright, so let's take the partial of this guy with respect to y. Alright, so square the bottom, x squared plus y squared. Alright, then partial of this guy with respect to y is actually 0, times square root of x squared plus y squared, so that's 0 anyway, minus x times, right, so partial of this guy with respect to y, we've done it before, it's a y over square root of x squared plus y squared, right, so this is going to be negative xy over, right, x squared plus y squared, and 3/2 power. Alright, then we realize that, so we did all this work, and let's find a quantity d. Then you realize that if you try to do f second partial with respect to x, evaluated at the 0, 0, then we already have see a problem, and it actually makes the denominator equal to 0, so this is undefined. So what we can do is, I guess there should be a choice, list of critical points for which second partial test fails. This actually fails because we can't do the second partial test, right? So maybe I have to put does not exist for that one, and does not exist, and does not exist, does not exist, and does not exist, and does not exist, maybe. Alright, so let's check the answer. Submit for testing. Alright, it came back, and I got the one wrong. It says that the relative minimum should be there. Alright, so let's step back and think about it. So we have this critical number point 0, 0, which is the origin, and would that be a relative minimum? Right, so second partial test didn't work, but a relative minimum actually exists. Right, because look at this function. This function is never negative, so the smallest number it can get, it's going to be 0. So if you put x equals 0, y equals 0, you can actually achieve 0. So relative minimum would be 0, and it's going to occur at point 0, 0 at the origin. Alright, let's check that, and sorry about the mistake there. Alright, it came back, and looks like we got these guys correctly. Alright, that's it. I hope that this was clear.